So in our last video lesson for this unit, we're going to apply compositions of transformations. And all that means is when we do two or more transformations that are combined to produce a single transformation, that's what we call a composition of transformations. So along those lines, if we do a composition of two or more isometries, then the whole composition is what we consider an isometry. However, if I combine an isometry and a similarity transformation, then we can't call the composition an isometry. So for example, if I do a translation, which is an isometry, and then a reflection, which is an isometry, then that whole composition is an isometry. All right, so in this first example, we're going to sketch the image of CD, and here's CD is 2, 0, and 3, 3. That's CD of this reflection and rotation. So you always do it in the order that they give it to you. So first we're going to reflect in the x-axis, and then we're going to do a rotation 270 degrees counterclockwise. So if I do a reflection in the x-axis, then since C is on the x-axis, that will stay put. And D, if I draw that perpendicular, is 1, 2, 3 units away. So following along that perpendicular, it should be 1, 2, 3 units away. So that's the first part. So I'm going to label this as C prime, D prime, only because that's going to represent the first part. All right, so that's going to give me C prime and D prime. And then after I do the rotation, I'll call that double prime. So now my points for C prime and D prime, I'll go ahead and list them. We have 2, 0, and 3, -3. And again, you can either do that visually or with the rules we've been doing. So now that we're doing the 270 degrees rotation, that's counterclockwise around the origin, you could either rotate your paper 270 degrees counterclockwise. Mine's going to be difficult to do that because my points are not attached to that grid on my smartboard. So I'm going to do that by the rules that we did. Remember that the rule for 270 is I'm going to switch them and then make the new y coordinate the opposite. So for my C double prime, I would switch them, and then now this 2 would become negative. For D double prime, I would switch them, and then that 3 in the y coordinate would change from positive to negative. So let me plot those, 0, -2, and then -3, -3. So that's my C double prime, D double prime. All right, so this is where I would end up after I do a reflection, then a rotation. Now, what we're going to do is we're going to do the same process, but I'm going to switch the order. So we're going to do the rotation first, and then the reflection. We'll see if that affects anything. So I'm going to erase all this. And I'll do this in blue. So if I do the rotation first, that would mean that from these points, if I follow my rule, my C prime would be 0, -2, and my D prime would be 3, -3. So let me plot those, 0, -2, and 3, -3. And now if I do the reflection over the x-axis, this is 2 away from the x-axis, so C double prime would end up here. And then this is 1, 2, 3 away, and D prime would end up where original D ended up. So those would be my new C double prime, D double prime. So does it make a difference? Yeah, it does, because we're ending up in a completely different spot than we would have if we did the different order. So that's why it's so important to follow the order that it's given. All right, so now let's look at this. Oh, that's the same one. Okay, so I didn't have to do it on the same one. So now let's look at translation and reflection can be performed one after another, and they have a special name for it called a glide reflection. Okay, so which should be first, the translation or the reflection? Well, what do you think? What comes first in the name? Glide, so that's the translation, should come first. All right, so here we're going to do a glide reflection. So here are our points. Let me move that. All right, so I'm going to plot Q, which is 2, -3, 4, -4, that's R, and then S is 5, -1. So Q, R, S. So first we're going to do the translation of x comma y plus 5. So that means all of our x's will stay the same, but our y's will be increased by 5. So I'm moving all of these points up by 5. 1, 2, 3, 4, 5. There's Q prime. 2, 3, 4, 5. Here's R prime. And 1, 2, 3, 4, 5. There's S prime. So that's the glide part. We're not finished. Now we have to reflect in the y-axis. So now I'm going to take all these points, reflect over the y-axis. So this one is 2 units away from the y-axis. So stay along that perpendicular. That would be my Q double prime. This is 1, 2, 3, 4, 5 away. So that would be 3, 4, 5. That's S double prime. And then this is 1, 2, 3, 4, 1, 2, 3, 4. And that would be my R double prime. So this is where I end up. So my Q double prime is -2, 2. My R double prime is -4, 1. And my S double prime is -5, 4. So that's what we consider a glide reflection. All right, so now what happens if we do the same type of transformation in our composition? So here's one specific one where I'm going to do a double reflection. So here in this double reflection, my lines of reflection are parallel. So I have K and M are parallel. And if we do a reflection over K followed by a reflection over the line M, then here's what we know about P and P prime. So let's say this is point P. If I do a reflection over line K, then that's where P is going to end up. And then if I do a reflection over line M, and again, I'm estimating, so that's what it would look like. So first of all, segment P, P prime. So if I connect P to P prime, P double prime, is perpendicular to both K and M. And that makes sense, right? That's how we create a reflection. We always have to find the perpendicular lines. So if these are parallel, then all those perpendicular lines will be the same. All right, and then P prime, the distance from P to P prime will be 2D. And they're considering D the distance between the two parallel lines. So let's think about why that would be true. So whatever this distance is, we don't know what it is. Okay. I know that will be the same, right? Let's call that distance A. Okay. And then again over here, from here to here, I don't know what that distance is, but I know that will be the same. Okay, so if I look at D is made up of A plus B, and then the distances on the outside are made up of A plus B. So that's why it's like I have 2 different D's added together. All right. So very similarly, If I do a double reflection over intersecting lines, so now these aren't parallel, but they're intersecting, and here they're calling the point of intersection P. Okay. Then the reflection in K followed by reflection in M is the same as a rotation about point P. Okay, and that angle of rotation is going to be 2 times x, where they're considering x the degree measure between those intersecting lines. Okay, and I think this one is better seen and makes more sense when you have an example. So here we're going to have these 2 lines, M and K. They intersect at point P, and the angle between them is 68 degrees. So if I take a segment, HJ, reflect it over K first, and then take that reflection and reflect it over that, then they're saying if I go all the way from H to H prime, double prime, that angle is going to be twice of what this angle is. So that's going to be 2 times 68, which will be 136. And again, for the same kind of reason that we were doing before, if I just go from, I did that angle incorrectly, I drew that incorrectly. This should be from here to here. So if I break up that big blue angle into the 2 separate reflections, so first I go from here to here. Again, I don't know what that angle is, okay, but I know that this angle here and that angle there are congruent. And then if I go from this one to this one, again, I don't know what that angle is, but I know that this angle right here and this angle right here are congruent. The green and the red inside add up to be the single arc plus the double arc adds up to be 68, because that's what it told us. And then I have another green and a double arc on the outside, so that's why we're doubling that. Okay, so both of those double reflections, we're basically doubling the distance between, whether it's an angle that we're doubling or the actual distance, like a segment length. All right, so we'll do some more examples in class, and you can ask questions that you may have.